Hi, this is Dr. Green. We're working on Web Assigned Homework 7, problem number 8. So here we're using the Pearson correlation coefficient to study the dangers of marijuana use before driving. It found a positive correlation here between marijuana use before driving and car accidents. So those are our two variables. And they told us that R, the coefficient of correlation, was 0.46. And the sample was 33 participants. So R is 0.46, and then 33 participants, that's going to be our sample size, N is going to be 33. And they want us to do a two-tailed test at the 0.05 significance level to state whether the decision should be to retain or reject the null hypothesis. So remember when you do this hypothesis test that your null hypothesis, we want to decide what we're testing here, is that the two variables are related, and then your alternative hypothesis is that they are not related. So we could actually write those like this. H0, our null hypothesis, is that the slope of the regression model, which we're using, your book likes to use rho, Greek letter rho, R, that looks like a P. So slope equals 0, which means x is not related to y. So in this case, our x is marijuana use and our y is car accidents. So the null hypothesis says that marijuana use before driving, car accidents are not related. And the alternative hypothesis says that the slope is not equal to 0, which means that they are related. So marijuana use and car accidents are related. So it's based on, here we're not given data, but it's going to be based on R is 0.46. So if you're not given data, then if we go back to our formula sheet 3, exam 3 formulas here, and we're looking at hypothesis testing because they asked us to do a hypothesis test. So here's our null and alternative hypothesis. So I already brought those in. And if you are using data, then what you want to do here is by hand, your degrees of freedom are going to be n minus 2, and your R value is going to be your test statistic. And then you check to see if R is more extreme than the critical value from table B.5 on page 666. If that's the case, then we'll reject the null hypothesis. Now, if we had data, we do as we did in previous problem and just look at the significance level in the SPSS ANOVA table. Okay, but we don't have that. So we need our degrees of freedom, R is our test statistic, and then compare that in table B5. So degrees of freedom here are n minus 2. And so that's 33 minus 2, which is 31. And then our test statistic is R, which is 0.46. And we want to check and see is that greater than the critical value. So we go to the book here. We are testing at the 0.05 level. So alpha is 0.05. And it's two-tailed test. And now we'll go to the text. So here, page 666, table B.5, critical values for Pearson correlation. Okay, so our level of significance here, this is level of significance for two-tailed test here, and it's one-tailed up here. So two-tailed is this bottom row, and we're at 0.05 in two tails. So we're going to use that second column, and then our degrees of freedom are over here. And our degrees of freedom were 31. So you want to go down the degrees of freedom column until we get to 31, keeping the second column here. And on to the next page. So they don't have 31, but the closest thing they got is 30. And then the 0.05 significance for two tails is the second column. So that's 0.349 right there. So that 0.349 is our cutoff. And indeed, our R value, which is our test statistic, is more extreme than the critical value, the cutoff here. So we are going to then reject H0. And so here, reject the null. So if this ended up being less than 0.349, then we would retain the null. So that one you have to do by hand because you don't have the data.